We're asked to find this antiderivative. You might be thinking, wow, where do I start? This looks complicated. So this one is set up perfectly for us to use some sort of substitution to help us find the antiderivative. Okay, because right now we have something to the 6th power. We could expand that, but it would take us forever, and then we could go term by term. A quicker way is to just say, let's take this huge power and let's write the term on the inside. Let's make that simpler. Let's make that be u. So u is going to be negative 6x squared minus 1. So that means du is going to be negative 12x. Okay, I took a derivative of this term with respect to x, and I got minus 12x. So we need to be able to substitute every x with u if we're going to change the variable of integration. So here, let's write what we have. Taking an antiderivative, we still have that minus 4x. We can't directly substitute that right now, but this entire term, because of our substitution, is now u to the 6. Okay, but there's still an x, and we don't have du like we're supposed to. So the way you're going to get that is by somehow rewriting so that you have minus 12x instead of minus 4x. And that's a quick fix. Look, I just need to multiply this by 3 to turn it into minus 12x, right? So go ahead and do that. Do 3 times this term. But it's got to be the same integral. So we've got to balance that by multiplying the outside by 1/3. Okay, so see what I did there? The 1/3 times 3 would make 1, so we're not changing the original integral. But by multiplying this by 3, I now have my du. So that's minus 12x in here. Here, I'll write it out. So that is du. And we usually put the variable of integration after, so I'll rewrite it like this. Okay, there we go. So now we can find an antiderivative. So again, when you use substitution, you have two goals. You want to substitute probably the most complicated term, but you have to choose how you substitute in such a way that du also exists. All the x's have to be substituted. So I need to do a little bit of rewriting with constants, and then I was able to substitute this with du. Okay, now it's just integration. I need the power to go up because I'm taking an antiderivative. So the new power is u to the 7th, and I'll put a 7 on bottom. And so I can multiply those constants. But then they wanted it in terms of x, so all you have to do to finish this, sorry, this is plus some constant c out here. When you take an indefinite integral, meaning you don't have limits of integration, there's an infinite amount of constants that can be over here, so plus some constant c. Because when you take a derivative of a constant, it makes nothing. So anytime there are no numbers here, when you find your antiderivative, you've got to put plus c. The last step is just to plug in our substitution, negative 6x squared minus 1. So negative 6x squared plus 1 to the 7th over 21 plus some constant c. So now we're done. You could take a derivative of this term to check, but if you do, it should turn back into this term.